So just I'll give the revision for that. So far, what are the main concepts we completed? Okay, na? So here simply about the NumPy. Okay, what is the NumPy library and what is the purpose of the NumPy library? Why it is used in the real time? So simply for fast execution and one more is it is required for various libraries like a pandas, CP, scikit-learn. In many areas we are using this one. This two important. And how we installing, how we are testing that version completed. So main point here, the how to create the array objects using the NumPy. How to creating the array objects using the array function mainly we are creating. So we have so many variations. Yes, we have so many variations. Okay, array function, zeros function, ones function, fill function, array range function, a range related. So okay, like several things there. So these all again in the last session I explained clearly how to creating 1D, 2D, 3D array objects. After creating the array objects, and also I used indexing and slicing concept. Working with indexing slicing. 1D related indexing slicing, 2D related indexing slicing, 3D related indexing slicing. I hope everyone remembering about these all things. Okay, no? And next, difference between the copy method and view method related. I explained guys the difference between the copy and view method. Okay, one program I did for that. So check it here. That this is my array guys with 1, 2, 3. So using the copy method, a new array I created. Using the view method, new array I created. So copy method behavior is it is creating the new object guys. The main difference between a copy and a view of an array is that copy is a new array and view is just a view of the original array. It means using copy method we can create the new object with original object elements only, but memory is different. Okay, but using the view function, same object only we are using as it is like assignment operator. Okay, so now finally two objects I'm creating here. So in main object, in original object, if I'm doing any modification, then view object representing with the main object only guys, associating with the main object only. That's why the changes coming into the view array object. But in copy array object, no changes are there. Why means it is a different memory. So original object here is there using the copy method, new object is creating, but using the view method, same object only representing. So in one element place, if I'm updating any other element, then that is not reflected to here. So only using this variable or using this variable. Okay, first variable is array one, second variable is view array, view array. Using these two things, same object we can represent holding as, and using copy array we are holding this one, representing this one. Okay, so remember this point. Sometimes in interviews asking us what is the difference between view and copy. So you have to explain that all, and one example you have to prepare for that. Okay, so copy owns the data and any changes made to the copy will not affect the original array. Simply using the copy, we are creating new object. In that object, if you are doing any changes, that is not reflected to the original array. Or else in the original array, if we are doing any changes, that is not reflected to the copy object. But a view does not owns the data. It means any changes made to the view object will affect the original array also, or any changes made into the made to the original array object will affect the view object. Hope you are understanding about this one. All of you clear this one? It is a very, very important one, NumPy related, copy and view related. How to check if an array owns its data, like if you want to check it guys. So this NumPy providing one attribute called base attribute, checking related. I'll give you one program for this. How to check if array owns its data. So simply I'm creating, okay, two things guys. Same above program only copy and pasting. So using the original array with the copy method, new object I created, using the view method, new object I'm creating, and print guys. So print here copy object, dot base attribute is there. So base attribute, and next print print view object or view array dot base we can use. So base is an attribute, guys. It returns either none value or original object. None value if it returns, then it does not owns the data, guys. I mean, it owns the data means new copy creating. So for copy method related, you can see here copy method related object new object. So base returns none means it is like a new object. This is not a original object meaning. So view method representing original object only, guys. View method holding the original object memory only. So that's why base returns original object elements only. Simply it is like original object. Okay. So how we are checking means using the base attribute we can check it. If returns none, that is a new object. If does not returns none, and if returns original object, so it is holding the same object memory only, like you can understand. Are you clear about this one? In Python, copy method and assignment operator concept I explained the same like that working here. Agree, guys. Yeah, today a lot of points we'll discuss. So next, how to check if an array owns its data. Okay, already I explained this program. And next, how to iterate the arrays. How to iterating the arrays. Iterating means going through elements one by one. In an array, if multiple elements there, one by one, we are going to iterating using for loop kind of concept, guys. In Python, iterating the elements from the sequence object using the for loop we are performing, guys. So as we deal with the multi-dimensional arrays in NumPy, we can do this using the basic for loop of Python, and also NumPy module providing more advanced one, NDITR method, n-dimensional iterator, like that. Okay, check it here. Now here the NDITR directly I explained, guys. So here I created a three-dimensional object, two-dimensional, two slices, three rows with three columns, guys. Okay, na? So it is three values there means three-dimensional object. Only rows and columns there means two-dimensional. Okay, slice also there means three-dimensional. Remember. So from the three-dimensional directly we can access, guys. Directly we can access using the NDITR method. Simply here. First of all, without using NDITR method, simply I'll give you here, first here, normal for loop, guys, accessing the n-dimensional elements values. Okay, na? Okay, all commented, no problem. Just check it, guys, here. Check it here. I'm removing this one. First, okay, here I'm commenting. Okay. Again, this one also commenting. Okay, my God. So with this one, using the range function, 18 elements related array creating 1D array. That is using the reshape method as a 3D I'm creating, guys. So first 3D object can return. This is a 3D object, 3D array object. Okay. So this array object related elements I want to accessing, guys, here. So each scalar value means in-depth level value. Okay, direct values, guys. So each one I want to access and I want to return. So if it is n-dimensional n number of times, so we have to iterate using the for loop for accessing them. So now you can see here this is a general for loop concept. First, using this array, from this array, slice two slices there is a three-dimensional. Each slice we are getting that we can print it. In each slice, three rows there, guys. So from each slice row we are getting every row. From each row, three columns there, three times repeating. So from column in row, then directly column I'm printing. Here slash n is there, vertically displaying. So one space I'm using, horizontally going to displaying. Okay, now? So we have to write like that. See, this is the three-dimensional object. If we want accessing those elements, see here the many loops I created, guys. Many loops I created. Okay. So now check it. You are getting all the values. If it is a 10 dimensional, if it is a 10 dimensional, then 10 times loop required, no? Multiple loops. A loop contains another loop, again that contains another loop, like that. It is all making a lot of complexity in our code, guys. Okay, complexity of the code increasing. So to overcome this problem, we are going to use NDITR function. NDITR function. Okay, after printing this all, so one more print statement I'm using, and now I'm going to use it. All in one program only I'm explaining. So NDITR, n-dimensional iterator function is there. So to this NDITR, directly our array, n-dimensional array object as an input we are giving. So directly from this array, scalar values accessing. Directly from this n-dimensional array, scalar values accessing. Scalar values means directly, I mean, in last level, what are the elements there? Directly elements accessing, each element getting that element printing. Okay, now check it here. So here the just two lines code only created, and here the somewhere the wrong statement there. Print. Now execute. So yeah, same output getting now. But here the like this many loops not required. Because of this, a lot of time taking as performance of the application decreasing, simply performance of the looping decreasing. Okay, so here directly inner level values we can access and we can print. It is more fastly executing. So this is the advanced one. If n number of dimensions are there, directly inner level values if we want to access, we can use this NDITR function. Okay, now? So above problem we can solve using NDITR function. So using NDITR function, okay, not ID, ND, using NDITR function. To this, our array as a input we are giving guys. Come on, let me know all of you clear about this one, this program. Without NDIR, using NDIR, what is the difference between them? So when you are attending the interviews, guys, like this n-dimensional object giving as input, how to accessing all inner level column values, how to accessing all columns, can you display like that asking. So that time don't write like this. Directly you can use NDITR function, then interview person satisfying well. Okay, now? And if you want, guys, based on the slicing also, we can filter the elements here. Based on the slicing also, we can filter the elements. So first of all, I think, okay, already above code commented. So I'll access that. Print array 1 and one empty print function gap. Okay. So now here array 1 is there. And here we can use slicing related, guys. We can use a slicing related. Based on the slicing also, we can access the elements. Based on the slicing also, we can access the elements. For example, one column, one column here, or else simply column, column, something, again column 2 I'm giving as a column 2 I'm giving. So now you can check it here. See here the totally 18 elements there, guys. Totally 18 elements there. So here the column 2 I given, guys. Column 2. What is happening here? Okay, check it here. Iterating the arrays using the NDITR. I explained this one. This function helping this function NDITR is helping function that can be used from very basic to very advanced iterations. It solves the some basic issues which we face in the normal iteration. Okay, so that is already did, guys. Directly inner level elements we are accessing. So now we can use the step size, guys. Iterating through every scalar element of the 2D array skipping one element. One element I want to skip and I want to print it, guys. One element I want to skip and I want to print it. Okay, so just I'll use this syntax. Okay, now here first, if not giving, why it is only one slice returning and one slice related elements only, why returning means, so here what happening, first 0 is there. 0 means first slice. So this is the 0 slice, this is the 1 slice. So first slice related. And next here not giving any input, guys. Not giving any input means in that three rows there, every row related. Every row related. Okay, na? So I mean here the 0 column 2, guys. 0 column 2 like that there. So 0 index 1 index, okay, like all the values related getting. So directly second index is the end value related. Okay, second value related, the end value related, guys. So first slice related every element we are getting. So this is okay, differently I'll use. Okay, this one you can use. Check it, guys, here. So now here only column is there, column 2 is there. Because of this, so first slice select all the elements previously we got it. And now check it here. So this representing array of starting value not there, ending value not there. Okay, it means every row, every row meaning. This is one row, guys. This is the two-dimensional array, and this is also one more row. Every row related. Okay, so here the starting 0, ending available length, each second value getting, each second value is getting, guys, here. So starting 0 in every row, end value is available length. So here 4 values there, so 4 means last index value is 3. So 0 to 3 indexes, every second value has, every second value. Actually, first of all, okay, if you are considering this one, these all values merging like a single array is there, guys. So starting 0 index to up to available length, every second element getting. So every second element means this one, and next this one, and next this one. Every second element you are going to get. If you are not using this condition, these all elements like a single platinum object wise returning. So now you can check it here. Okay, 1 3 5 7 you are giving. And if you are not using this condition, if you are not using this condition, so both rows related merging and returning. Okay, so this is the actual object. So because of the two step value, every second value we are getting a sum, this one, and this one, and okay, 1 3 5 7. Okay, 1 3 5 7 you're getting. If we are writing this input, same coming or not, check it. 1 3 5 7, yes, correctly working. All of you clear this one? Every row related second two elements increasing, guys. Okay, I'll give you that heading here. When you're working with the slicing, indexing related, a lot of times you have to do practice, guys, same like Python slicing concept, then more clarity you will get it. Okay, so okay, next enumerate using the enumerated iteration using the enumerate function. Enumerate function. So here in Python also we have a enumerate function, guys. What is the use of that enumerate function? Along with the values from this sequence, every value related index values also we can access. Index values also. So now here using this undo enumerate function. So every row related index value and column related index values, okay, all the information also we are getting from which row, which column related element we are getting, like that we are understanding, guys. Okay, this is what right now 2D, this is a 2D object, guys. For example, you can see This is the 2D. If I'm printing this array, so 2D object you're getting guys. Okay, 2D related. So this is the row 1. Row 1 means index 0 guys. Index 0, this is index 0 value. Next index 0, this is index 1 column. Index 0, index 2 related column. Like this entire information I want to get it guys. I want to get it. Okay, and I want to display. Yeah. So then write for loop for column, or else simply for I, like something. For column in nd enumerate np dot nd enumerate of our array can give as input, and now here print that column, print that column. So this is the 2D related. So now you can check it guys here. So 0 row index, 0 column index related value this one, and a 0 row index, column 1 index related value this one. And like we are getting as separately we are getting the value from this row. All of you understanding this one? So now check it here. Enumeration means mentioning the sequence numbers of something one by one. From this sequence one by one values we can access along with the index numbers guys. Sometimes we require the corresponding index of the every element while creating. Then we can use the undo enumerate method. It can be used for those iterations. Can be used for those iterations. Okay. Hmm. So now check it here. Each one having a tabular format, guys. I mean, package, unpacking, packing concept there. So if we are using like this index number we are getting, its index value we are getting. Just I used one variable directly I'm printing as. If you are unpacking like this properly, you are able to get it in. So here in this, it's like a packed object. Row index number, column index number, and its value, everything we are getting. So here, for example, I comma j, you can use as I comma j. So you are unpacking as you are unpacking, and now here I comma j, like you can use I comma j. Hmm. Unpacking concept. Then previously here the array object of 1, array object of 2, array object of 3, like that. Object format written directly values we can access. This is unpacking concept. In Python only people knows. So by seeing this one, you will understanding is 0, this one representing 0 index row. In that 0 index column contains 1, index 1 column 2, index 2 column 3, index 3 column related 4. Okay, in 0 index row, and these are representing column indexes. In this, these values are there. And next, 1 representing index 1 related row, and column indexes representing having these values. Are you clear here using this enumerate function behavior? So first one is index related. Then for understanding purpose, IDX, like we are using our index, you can use and its value here, index comma value, and those variables you can use index comma, and now here the value we can use it. That's it. Meaningfully we can print it. This is the 2D related only. Next, if it is a 3D object is there guys, okay, I will use here array 1. So array 1 is a 2D related assumption. And next I want to create one more array guys, one more array. or else directly you can create arrays using the reshape method instead of writing many elements. How to creating using the reshape method? So import a module as a np you are importing, and the np dot range function, guys. Range function we can use, and here the 1 comma, for example 19 I'm using, 1 comma 19 means totally 18 elements there. So now here reshape I'm using. I want two slices, 3 rows, 3 columns related. 2 into 3, 6, 6 into 3, 18, guys. 2 slices, 3 rows, 3 columns related. So here array 1 something, array 1 equal to array object, this one. And now you can print this array object. What is getting, can see here. Now see here, 3-dimensional object you are getting as 3-dimensional. So I want to write this syntax. Array 1. Now can see here. So here the slice value, row value, column value, column index, slice index, row index, column index, all you are getting. So 0 slice related, these all representing 0 slice means first object, guys. First array object related. So these all 0 index related row, index 1 related row, index 2 related row. So in index 0 related, okay, every column related values, guys. These column related indexes. In 0 slice, 0 index row, 0 index column related value, this one. In the 0 index, 0 index row, this is a slice, this is the row, this is a column index, there 2 is there. Like that, all representing here. By seeing like that, you will understanding this. So in slice 1, index 1 related row, 0 index column contains this 13 value. Okay, now I'll have you clear this one. ND enumerate function behavior. Working with 1D, working with the 2D, working with the 3D, to do practice, guys. It's all available in the material, guys. So do practice. Your practice is important. Okay, now? And next, working with NumPy data types, guys. Working with NumPy data types. First of all, data type is what? A data type is a way to specify the type of the data that will be stored in an array. In Python also we have data types, so many data types. So whenever we are assigning the value to a variable, what type of memory is required deciding by this data type concept. Python follows the dynamic data type concept, dynamic memory allocation. That's why no need to defining before the variable name data type. Based on the value itself deciding. Python can deciding what type of value this one and what type of memory is required. Okay, so that is a data type related case. Check it. A data type is a way to specify the type of the data that will be stored in an array. Stored in an array. So NumPy offers a wider range of numerical data types that numerical data types than what is available in Python. In Python only into float like there, guys. So here the so many numerical data types it is providing. Some list of available data types I'm showing here, guys. Just check it here. Int 8, 16, 32, 64 like there, guys. Int related 8-bit, 16-bit, 32-bit, 64-bit format there. Signed integer types with different bit sizes. With different bit sizes like that. Unsigned, U means unsigned integer types with different bit sizes. Floating related, float 32, float 64 there. Floating point types with different precision levels. Precision levels after the point, okay, real number, fraction numbers like that. Precision means. And complex related, complex 64, complex 128 like that. Complex number types with different precision levels. Okay, okay, simply like this, so many data types there you can consider, guys. Whenever we are creating the complex object, so these data types representing float related, this one, This is higher memory related. By default, higher memory related creating. Okay, int related 64 is the higher memory. If we want this, how we are creating, how we are saving the memory, can check it. For example, int 8 related this size memory. Okay, and for 16 this size memory, and for 32 this size memory, for 64 this size memory is creating for storing the value. So for storing a small number, guys, instead of creating this size memory is creating more efficiency. Okay, so for that we have to create explicitly, guys. So how to creating explicitly? Now we'll see about that. Create one array object, guys. Create array object here. So now here array 1 equal to np dot array function you can create array function and a list of values, something values you can write if you want some values. This is one array object, guys. So now here just print this array, just print this array. It's like a 1D array, one dimensional array you're getting. Okay, so it's a data type. I want to check it, guys. Here data type, how we are checking? D type attribute is there. D type attribute. Simply here the string format message, if you want you can write array data type. Array data type is so int 64 format you're going to get it. Int 64 by default. Okay, here if any floating number there, the float 64 like that coming. If any complex number there, complex 128 like that coming. Higher memory type. Okay, now. So how to identifying the object data type using a D type attribute? NumPy provides so many attributes. Yes, so this is the finding using this finding the data type. Okay, next I want create the same object with less memory. Yes, with less memory. Then at the time of creating the object only we can specify using the D type attribute what type of memory is required. Okay, okay, that is I will let you know. First of all, here the int 64 there, I want to convert into other type, float type. If we want to convert into other type, as type function we are using as as type function we are using. So for example, here the print our object array one dot as. Okay, here first assign to the variable array 2 equal to as type function. As a type function. Now here float related I'm using, and next array 1 data type. Now here array 2 data type is you can check it, guys. Now float related you're getting d2. Okay, here the how to change this one. Okay, float 64 format converting. So how to converting one type data into another type means using as type function. Remember that which type we want, the data type can use. Okay, and next at the time of creating only, if you want to specify which type of memory is required like that, so you can define like this. Array 3 equal to, now here by default 64 into 64 format there. So D type equal to which type you want. D type equal to, now here the int 16 I want is int 16. Now here print array 3 related. Array 3 data type is array 3 dot D type. And now here the you can use, okay, I think now can see here int 64 format generating. By default int 64 format generating, now 16 format generating is int 16 bit, 16 bit less memory, 64 more memory occupying. Okay, na? And by bits size also, element size also we can calculate. I will let you know. Just wait. So hope you are understanding. At the time of creating object only, we can decide what type of memory is required using the D type attribute as an another argument to this array function. Okay, array object comma D type attribute. Or else after creating, if we want to convert into other type, then AS type function can use. That is the concept. Okay. So now we have so many attributes, guys. We have so many attributes which are provided by this NumPy model. Can see here. Okay, AS type function I explained and D type related explained, guys. So NumPy array attributes. So in NumPy, attributes are the nothing but properties of NumPy arrays that provide information about the array's shape, size, data type, dimension, and so on. About our existing array object related shape is what, size is what, data type is what, dimension is what, memory is what. Okay, like we can get it, guys. To get a dimension of an array, we can use the ndim attribute. Already I explained, guys, previously. So check it here. Using this one, data type is what we can understanding using this one. And if I'm using array 3, for example, array 3 dot ndim attribute. Previously we discussed using this dimension we are getting as dimension we are getting, and next array 3 dot size. Using this, how many elements there in that array size we are getting as 3 elements there. So one dimension, 3 elements available like that we are getting as. So side message if you want, you can write here one dimension one dimension array, and here so elements available elements available like that. And next print array 3 dot ndim size d type already explained above. Okay, okay, no problem. Shape we can use, guys. Shape, so it representing shape of the object. Is it a 1D, 2D, 3D like that? So only if displaying like that one value between the parentheses, it's like a 1D. 1D. If two values there, comma separating, 2D. If three values there, that is a 3D object like that. 3D array. Okay, it means three elements there only. Three elements there in single row, guys. That is the meaning of that. Using the shape attribute, we can get it. If it is a 2D, you will understanding 2 comma 3, 2 rows, 3 columns like that, you will get it. Okay. So now here print array 3 dot item size, guys. Item size attribute is there. So now check it here what it returns. Item size bits returning as 2 bits. 2 bits. So here int 64 format there, int 64 format there, array 3. For example, here array 3 related, okay, array 3 is a 64, 16 related. Array 1, array 1 contains 8 bits, guys. Every element contains 8 bits. Okay, I means by default this array object creating with the int 64. For int 64 format related, every element contains 8 bits. Every element occupying 8 bits memory, guys. Every element. Now, how many elements there here? Using this size, we are getting as 3 elements there. So, array size into item size, array item size. If we are multiplying, so total how much memory is required, how much bytes required for this array object in memory we are getting as. So sometimes asking, this is my 1D array object or 2D array, 3D array, like giving one object, and how much memory or else how many bits required for this array for storing in memory. Okay, for storing this array object in memory, how many bits required? Nothing but memory size asking. Okay, that time your syntax is array dot size representing what are the how many are the elements there, count returning into item size for every element how many bits it is occupying. So you will understand. Okay, so here the one calculation, check it, guys. Here for 64 related 64 64 related 8 bits, guys. It is occupying the 8 bits for every element in 64 into 64 object. Every element contains 8 bits memory. Okay. So now here the int 32 of guys reducing. So 4 bits related occupying. And next int 16 occupying 2 bits. 2 bits. Next int 8 it is occupying every element occupying 1 bit. 1 bit, guys. This is the size related. Int 8 1 bit for every element. For 16 2 bits for every element. Int 32 maintains 4 bits for every element. Int 64 maintaining 8 bits for every element. Okay, based on that you can calculate it. So right now here how many elements there in this array? In this array 3 elements there, and this data type here the d type int 64 is there. Every element occupying 8 bits. 3 into 8 24 bits size required for this entire array storing in memory. Okay, na? So based on this data type here the int 64 for 8 int 8 1 bit, int 16 2 bits, int 32 4 bits, int 64 8 bits. Like you have to calculate it, guys. Okay, na? And, so right now here array 1 8 bit for every element. So here I'm going to use array 1 dot size, array 1 dot size size 3 elements there, guys, into array 1 dot item size. Okay, na? So this is a total memory, guys. Total bits required for array 1. Okay, 24 bits required, guys. Okay, it may be ND, 2D, 3D like that. You can check it. You will understand it. Okay, na? Now these attributes repeatedly we are using it. Check it. NDIM is for identifying the dimension of the array. Size, how many elements are there? It returns the number of elements in the array. D type returns the data type of elements in the array. Shape returns the size of the array in each dimension. Okay, na? 2 rows, 3 columns like that. Shape returns. Item size, it returns the size in bytes format, guys. It returns the size of each elements in the array. In an array object, each element how many bytes occupying. Okay, that returns using the item size. So data, this one, it returns the buffer containing actual elements of the array in the memory, guys. So buffer is nothing but memory address, guys. Okay, you can check it here. Print array 1 dot data, array 1 dot data, what it returns, can see the output. So memory related representing as memory at so and so. So this array 1 related memory address is this one. This array 1 related data is available in this memory location, like that, representing memory address. Are you clear? All of you. These all attributes. Okay, here for that examples I given. Okay, no problem. So creating arrays with numpy dot random module. It's related later. I will check. I will explain, guys. In the next session, I will explain lot of variations with the task wise. I will explain. Okay, skip this one right now. And next array operations later. Before going to discuss in the array operations, so I will do some other examples, guys. For practicing purpose, from the array objects, rows and columns related practicing purpose, some examples we will do practice here. I have one requirement guys. How to reshape the 1D array object into 3D array with rows and columns related, specify rows and specify columns related. Like if we had, I mean, if anyone asking reshape method we are using and how many rows required, how many columns required, these all we are representing this. These all we are representing. Okay, so here some advanced ways also we can do it, guys. 1D array I want to convert it into 2D with a single row only. With a single row only, guys. That is my requirement. How we are doing? Can check it here. Okay, this all I'm commenting. To practice, guys. These are attributes related. Using attributes. Sorry. Now here array 1 equal to np dot array function of so elements we can create, or else directly instead of typing numbers like this, a range function you can use, guys. So 8 elements related one array object I created, one array object. So I want to convert, guys, this 1D array object with 8 rows and 2 columns related. How to do, guys? 8 rows and 2 columns related I want to do it. Okay, directly I will print. I want to save it. How we are converting, guys, this array? You can use array1 dot reshape. Reshape. I want 4 rows, 2 columns related. So directly I'm printing 4 rows, in each row 2 columns there. The same syntax you can also do with another way, guys. The same behavior. So np dot reshape directly from the np module. Okay, numpy module reshape we can use. To this first input our array object we are giving, and now here you can define the dimension 4 comma 2. Like this also you can do it. Both are correct only. Okay, same result getting. Array object dot reshape of dimensions you can define, or else np dot reshape of array object as input. This object using this shape attribute 4 rows, 2 dimensions, 2 columns wise. 4 rows with each row contain 2 columns wise reshaping. So both are the same one. Don't get confusing. Clear this one? Reshape related. Now this one, if we want, we can assign to the one variable, guys. Okay, this is the array 1. Okay, I will assign, I will reuse it, guys. Result 2, or else array 2 you can use. Array 2 equal to, so new one, and that is we can print it. It's simply array 2, array 2 printing. Same like here also, array 3 equal to, and print array 3. So all error gone, guys. You can print same result you are getting, no problem. And next, right now here, this one array 2 or array 3. This is nothing but a 2-dimensional object. Na? Ndim attribute we can use. Ndim attribute. You will understanding what is the dimension for this one. So two display means 2-dimensional object. This 2-dimensional object I want convert into 1D Hmm. How to converting guys? The two-dimensional object I want to convert into 1D. Array 3 equal to now how to do using flatten using flatten method. Okay, I'll check it that array 2 or array 3 is nothing but two-dimensional only. So now here flatten, okay, flatten I'm using, and next here array 4 you can use array 4, and print guys array 4 you can print. See here 1D, like this 2D object is creating like a 1D using flatten, and using reshape method also we can do it. I'm telling that one, using reshape method also we can do it. So array 5 equal to np dot reshape method, np dot reshape of array 3. Array 3 is a two dimension guys. Okay, comma -1 we can use guys. -1 can use, and then print it. If we are using -1, it contains any dimension, all inner level column values accessing and creating like a 1D. So working or not, you can check it. Yes, same result now. Okay, depending on your requirement, whatever you are remembering, you can use that guys. Directly flatten method you can use, or else this reshape method only you can use. So here it may be 2D or 3D or ND, no problem. -1 if you are using, so it is converting into 1D. This is also another variation. Task related asking guys, using the reshape method, how to converting n dimensional array object into one dimensional. If asking, you have to use this syntax. If they are asking n dimensional array into 1D, how to converting, then any function you can use. That is your wish. Hope you are understanding all points. Hmm. And next here, this array one is which type of object guys? One dimensional array. So this array one I want create or I want to convert as a two dimension, but one row only I want. One row only I want. With one row, all the elements I want to display as a two dimension object, as a 2D object. How to do? You understanding my question? Array 6 equal to array 1 is a one dimensional object guys. Array 1 is one dimensional object. That is I want to return like a two-dimensional object. So using the reshape method guys, we can convert 1D array into a 2D array with a single row. So for that you can see here the np dot reshape method. Np dot reshape method our object. So array one is a one dimensional guys, and reshape I'm using 1 comma 8 I'm using 1 comma 8. Print array 6. Print array 6. So here the one dimensional array contains 8 elements. So 4 comma 2 means 4 rows to 2 columns like a 2D creating. But I want 2D, but a single row means 1 comma 8. One row contains 8 elements. That is only, say, 2 square bracket, that is 2D. Array of single array of single row contains 8 elements. 1 comma 8, one row with 8 elements. Is that clear, everyone? Mm. And modification also you have to understand, guys, how to array elements modifying, how to the modification related. Okay, these all elements I'm commenting, guys, or else okay, just like a drag and control slash commenting. Mm. Okay, now I have array 1D related array there, guys. So using this some other operations I want to do it. So in this array, these all values, guys, here, these all values, for example, these three values, I want to replace with some other value. I want to replace with some other value. First of all, how we are accessing these values? So indexing is there, guys, 0, 1, 2, like that. Or else the first three values I want to replace with other value. Okay. So array 1 of 0 column 3, then you're going to get first three values, guys. First three values really getting or not? Check it. Result equal to. So can print that result. Print that result from the array. First three values you're getting. Okay. Start index, end index given as a step value by default 1 is there, guys, here. The step value by default 1 is there. Okay, now. So now I want to replace with other values related. I want to replace with some other values related. um, in this array only if we want to do the changes. Original array, if we are assigning to the new variable, so only these slicing related array elements only we are getting, guys. So I want to just modifying this. I want to just modifying. So here array 1 only I will use array 1 only. So in this place, for example, 20 value I'm updating. So in 0 to 3 index related 20 value I'm updating and the new array I'm going to return in. So now check it here. First three values is updating with 20 value. Okay, now? So indexing, slicing, range we discussed, guys, and same like that start index, slicing related start index, end index, step value related also there. So we can use those all things. And now here next array 1 of from 0 to all available length, every second value is updating with a 0, is updating with a 0, and I'm going to printing array 1. I'm going to print array 1, guys. You guys see here? So started from 0, guys. Okay, starting from 0 up to available length, every second value updated with 0. Clear that one? So like we can get it, guys, array elements related. So modification related we are calling. So in material, I uploaded a material there, the n number of modifications related, indexing related, slicing related, like a lot of things there. Just to go through the material, you will understand, guys, those all points. So here, check it here. Okay, a lot of so indexing related there, accessing elements using the indexing. Go through this one and accessing the elements using the modifying the array elements using the indexing. Simply array of index number equal to value. This is the modification syntax. And if you know slicing, then using slicing also you can modify it. You can access it, you can modify it. Okay, negative indexing also working as so do practice modifying the array elements using the negative indexing also. So same like 1D, now 2D related, again same points, 2D related, again 3D related working as okay. So 3D related. all three things there. Two rows, two slices, three rows, four columns related like that. Okay. So NumPy array slicing here only slicing related. So far indexing related with 1D, 2D, 3D explained. Okay. Now slicing related start value, stop value, step value there guys. You know. So these all things there. So 1D array related like this. This is just accessing related. So different practices there. Just to go through this one, you will understanding. Already explained last session some points. And modification related. So here using the start value modification guys. Just start value given 0, 1, 2, 3. From here onwards, all the values up to available length. So 20 with the 20 value replacing. That's why you're getting like this. And next using the stop value replacing. Starting to third index guys. Means up to second index replacing. These all values are replacing with 40 value. Okay. And using start and stop range between this one guys. So updating with the 22. Now these values are updating with the 22. Okay. So start to stop and step related also. So index 1 to index 5 guys, every second element updating with the 16. So these values updating. So like that, all the things there. Now working with the negative indexing also. Okay, na? Just to go through this one with the 1D, 2D, 3D. Three objects related there. Reshaping related I explained guys. Using the reshape method how we are reshaping. 1D related, 2D related, 3D related. All the examples there. 1D array into 3D array how we are converting. So here dimensions we are using as with the reshape method. And flattened ND array to 1D array. Okay. So for that reshape of array object comma -1 you can use, or else directly your ND array object dot flatten function you can use, directly converting without worrying about this -1 and all. Okay. Two variations there. Copy and view related I explained guys. Example there, go through this one. Copy and view related interview point of view, very important. And next here using base attribute how we are checking, this also explained today. And iterating related normal iterations with 1D, 2D, 3D is there. What is the problem explanation there, and then how we are overcome that using the NDITR function. We are overcoming what is the benefit here, example there. Okay. And with the step size accessing related there, nd enumerate also there is ndo enumerate. Now coming to the joining numpy arrays. If we want to joining the two arrays, we can use the concatenate function and can join this. Okay, now comes to here